So we've talked about the fact that there are a lot of units that we can use for quantities of the same dimension. And so what we need to have is we need to have a process that we're very comfortable with in terms of going back and forth from one unit to another. So as an example, let's say that I told you that my height was 5 feet 10 seconds. And the first thing you would do is say that makes no sense whatsoever, mostly because I'm trying to add together things that have two different dimensions. That just doesn't make any sense. So one of the things to be careful about is when we add things together, I need to make sure that they have the same dimension. So you cannot add together quantities with different dimensions, right? So 5 feet 10 seconds doesn't make any sense. I can add together quantities that have the same dimension but different units. So 5 feet 10 inches, we say things like that all the time. The thing we need to be careful about is that I don't often take that height and you try to use it mathematically. So if I want to do that though, right? If I have some height that I know is 5 feet 10 inches, but I now need to do something with it mathematically, I really don't want that height to be given in different units, right? So that's the part that can be very dangerous. Is it's okay to add together things with the same dimension but different units. It just becomes risky to try and now do something with that. So the thing that we're going to do is convert everything to a single unit. Now that we have our quantity in a single unit, it becomes much easier to use mathematically without worrying about making mistakes. So we need to be really good at putting things together and going from one unit to another. So the key for combining or from converting from one unit to another is that units combine algebraically. Again, like we talked about before, units follow the rules of algebra. So that means that I know when I can get units to cancel, when I'm going to multiply units together, right? And so that's the thing that we're really going to fundamentally try and take care of. So again, let's say I have that height of 5 feet 10 inches. To turn this into a single unit, what I really need is an equivalency relation, right? So I need something that tells me how feet and inches relate to each other. And in this case, I know what that is, right? It's 1 foot is equal to 12 inches. And so now I've got some options, right? So I can take this height and I can turn it into something in feet as a single unit or something in inches as a single unit. And so let's just look at each of those processes, because to do that, what it means is I'm basically going to use this same equivalency relation, but in a slightly different form. So algebraically, I think we all recognize that if I take something and multiply it by the number 1, I haven't done anything to change what that is. Well, that's all we're doing when we do unit conversions. We just happen to be using a number 1 that has a funky unit, right? So because 1 foot equals 12 inches, right, I can think of 12 inches divided by 1 foot is the number 1. It's just the number 1 in units of inches per feet. Or I can think of 1 foot per 12 inches as the number 1 in unit of feet per inch. So what I'm able to do then with this equivalency relation is basically figure out, depending on which unit I want to cancel, how I need to write this relationship in terms of one side of my equation being on top of the other. So as an example, let's say I want to convert my height into feet. Well, mostly what this means is I need to set this up so that the feet that are sort of on top here will get canceled out by the feet on the bottom. So notice that in order to do that, I need to make sure that the feet as a unit go on the bottom in this expression. If the feet go on bottom, inches have to go on top. And so that allows me to cancel out feet. And so what that does then is it gives me a way to turn this expression into something in inches. So my height is going to be, I'm left with 5 times 12 inches on the top and just 1 on the bottom. So I get a final answer of 5 times 12 is 60 inches plus 10 more, so that's 70 inches. If I wanted to give my height in feet, well, so here what I'm going to do is I'm going to leave the 5 feet part alone, and now I need to convert the 10 inches into feet. And again, because the 10 inches, that inch is in the top, I need to set up this equivalency relation so that I can put inches in the bottom like it is here, so that I can get the inches to cancel out. And so if the inches goes on bottom in my fraction, then feet's going to go on top, which is good because that's what I want to be left with, is 5 feet plus something that has units of feet. And so basically this is, well, 10 times 1 divided by, you can think of this as 1 times 12. So there's that number, and again, I let my calculator convert that. It happens to be 0.83 repeating, and so I get 5 feet plus 0.83 feet, which is 5.83 feet. So this is the process that, again, I'm guessing you have done many times before in previous science classes, but we just want to make sure that we're really comfortable with. So let's look at one more example. Right? So let's say I want to convert from 60 miles per hour into meters per second. So one thing I'll sort of start up here at the top is make it clear, right? So when I think about my dimensions, I'm length per time is the dimension I'm starting with, and length per time is the dimension that I'm finishing up with. So notice that my dimensions don't change. What I am changing is my unit. So I'm saying I want to go, my dimensions of length, I want to go from being measured in miles to being measured in meters. And my dimensions of time, I want to go from being measured in hours to being measured in seconds. So that's what I want to keep track of. So in order to do that, well, the first thing I need is I need an equivalency relation. And so I'll start by taking care of my dimensions of length first, because I happen to know that 1 mile is 1609 meters. So there's 1609 meters in a mile. Again, I've got miles on top, which means that when I multiply this by a fraction, I'm going to put miles on bottom so that the miles can cancel out. If the miles go on bottom, that means meters got to go on top, and now it's just plugging in the numbers. So the 1609 still goes with the meter, the 1 still goes with the mile. So I've converted from miles per hour to now this is basically in meters per hour. Well, that's not what I wanted. I wanted meters per second. So now I need to think about how I'm going to deal with the dimension of time and convert it. Well, I do know that there happens to be 60 minutes in an hour, so I can start by multiplying by another fraction to cancel out the hours. And so in this case, since my hours is on bottom in my initial expression, to cancel that out, I need hours on top in my new fraction. So if I've got hours up here in the numerator, it's going to cancel out the hours there in the denominator. And so hours cancel out. And so now I'm left with an expression, my speed in meters per minute, which again is not quite what I want. So I've got one more equivalency relation, and I know that there happen to be 60 seconds in 1 minute. Again, minutes are on the bottom in what I've got right now, which means I need to cancel them out by multiplying by the fraction with minutes on the top. So if minutes go on top, then seconds have to go on bottom. That's going to let me cancel out minutes. And again, I'm just making sure that the numbers in my equivalency relation go with the right units when I plug them in. So I look at this, and my expression now has units of meters on top, seconds on bottom. So sure enough, I've gone from miles per hour to meters per second. And so I'm left with, I just need to multiply everything out, and so I've got the initial 60 times the 1609 on top times 1 times 1. All that gets divided by 1 times 60 times 60. So there's just setting up the math that I'm going through to leave myself with a speed in meters per second, and when my calculator tells me that it happens to be 26.8 meters per second. Now, again, this isn't the only choice I could have made in terms of converting from miles per hour to meters per second. Certainly in terms of dealing with the distance, since it only took me one step to go from miles to meters, I might as well just repeat that step, right? So I'm going to multiply by miles on bottom to cancel the miles on top in my miles per hour. Those will cancel out. And so I'm left with meters per hour. But it just so happens that I do know how many seconds there are in an hour, right? So I effectively can come up with the equivalent relationship that lets me go from hours to seconds in a single step rather than needing two. And again, to cancel out hours on bottom, I'm going to multiply by my fraction with hours on top. So the hours cancel out. And again, I've got meters on top now, seconds on bottom. And I just need to make sure that the right numbers go with the right units when I plug them into those fractions. So in this case, I've got my 60 times 1609 times 1, which will give me the meters on top, divided by now 1 times 3600 with the seconds on bottom. And again, that gives me exactly the same final answer of 26.8 meters per second. So you'll have plenty of practice working with this. And you want to make sure that this is something that you're incredibly comfortable with as we move through the class, because we'll be needing to convert back and forth between units all semester long.